Hey, have you heard about maximizing Linux performance with RAM file systems?
No, I haven't. What's that all about?
RAM file systems are a type of temporary storage that reside in volatile memory, offering lightning-fast read-write speeds compared to traditional storage options like HDDs or SSDs.
That sounds interesting. But isn't RAM volatile?
Yes, it is. But leveraging RAM speed can enhance application runtimes with extensive I/O operations, benefiting from improved runtime. One common strategy is placing files onto a RAM disk during the build phase to accelerate processes.
I see. What are the types of RAM file systems available in Linux?
Linux offers two main RAM-based file systems, ramfs and tmpfs. Both reside in volatile memory, ensuring data doesn't persist across reboots. However, ramfs lack size limits and may consume all available memory. tmpfs is a newer implementation based on ramps with added features and allows size limit configurations to enhance system stability by preventing one process from monopolizing all RAM.
That's good to know. How do you mount ramfs and tmpfs onto directories?
Mounting ramps involves using the command mount ramps with the tramps option, specifying the target directory, e.g., /ramdir. For tmpfs, you can set size limits and configure permissions using the command mount tmpfs tmpfso size equals 100k/ramdir and mount tmpfs tmpfso uid equals bob git equals bob/ramdisk respectively.
Wow, that's impressive. What's the real-time speed comparison between RAM file systems and traditional storage options?
Using the dd command, a 1 GB file is moved into a normal directory, revealing a write speed of 310 MB per second. The same operation in the ramps mounted directory showcases an astonishing 4.4 GB per second, 10 times faster than SSD.
That's amazing. Thanks for the informative overview. I'm excited to try this out on my Linux system.
You're welcome. Join us in enhancing your Linux experience through strategic RAM file system utilization.